So go to number 4, problem 4. This is a solve equation. This is probably about as basic of that we know there's simpler equations to solve than this, but it's probably like the best we could hope for on the test next week and on the SOL. Yeah, Connor?
For all of these questions that are under
Something very similar to it. Why? Because I'm trying to help you. Okay. 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 So, here, I gave John here. So, I mean, how would, if you just had to solve this straight up, so what I'm doing right now is I'm not just going through the math. I'm trying to help you like with strategies that will ultimately help us on the SOL. How would we generally start to solve a problem like that? Especially because this one is not multiple choice, so you can't just like plug it back in. What would you say? Yeah, I mean, you start by distributing on both sides, right? And remember, you have a calculator in hand. If any of this arithmetic is tough, I mean, you could do this. So I'm going to go a little quicker through this. So 2/3 times 9 should be 6. So it's 6x. 2/3 times 6 is 4. Right? 1/4 times 12 is 3. 1/4 times 4 is minus x. So by distributing, we were able to get rid of the fractions. It's not always the case, but in this case we're. Okay, next step. Right, we need to get the x's all on one side. Which x term should I move? The smaller of the two, which is what? The minus x. So how do I cancel a minus x? You add x, you add x. Right? Now we have 7x minus 4 equals 3. So now it's just a two-step equation. What are the last two steps? Add 4, 7x equals 7. Divide by 7, x equals 1. Okay, now the other thing I want to remind us, again it kind of goes into the homework we just did, is that for these equations, you always have the option of solving it like it's a system. Remember how that would go. Right? I would go to my calculator. Again, this is the kind of thing you might take a note on. Go to y equals, clear, and put the left-hand side of the equation on line 1. Right? Where do I find the fraction format? 2/3. Where do I find in the calculator? How do you get the fraction format? Okay, this is things you could be writing down for yourself, right? Alpha y equals 1. So I can put it in like it looks, 2/3, right? Then parentheses, 9x minus 6. Okay, then on the next line, go down to y2, put the right-hand side of the equation. Again, fraction format, alpha y equals 1. Alpha y equals 1. Put in my 1/4, parentheses, 12 minus 4x. Okay, now graph. That's the wrong graph. Okay, let me do this. Second, y equals. Okay. Let me do this. Zoom 6. There's one. There's the other. Again, how do you find the intersection point? Write these steps down for yourself. Second, trace, 5. And then what? Enter, enter, enter. And the x value is the answer. We don't care about the y values because actually there were no y's. We kind of introduced the y. So what is the x value? It's 1. So in either case, you get the 1. But if you, again, you're going to have to solve systems anyways, so you could always use the system to solve a 1 equation. Maybe that's easier. Okay, that was the number 1. Number 4. Let me get this. Doc, right. So this is number 6. This is also a solve equation, but this time it's a quadratic equation. And they've already given us the graph. Where do you look on that graph for the solutions? Okay, what are they on this graph? -4, +2, which makes which answer correct, right? Now remember, the x-intercepts, if you have to label those as points, right, then what is the point? X-intercept is -4, then the point is -4, 0, right? So for the x-intercept, the y is 0, and the other one would have been 2, 0. Okay, in this problem, they didn't ask us for that, but there are, I noticed on later they do talk about intercepts more. So that was the number 6. So maybe you make a note, right? The solutions to quadratic equations are the x-intercepts of the graph. Right? Okay, try the next one. Number 3. Another quadratic equation. Yeah, I mean, because they didn't actually give us the graph, right? Last problem was easy because they gave us the graph. This one, there's no graph, so just graph it. Yeah. We're on number 3 right now. All right, the number's in the top left corner there. I made sure to copy that in there. So remember, just go to the calculator, right? And remember, it needs to be the case that it's everything on one side, 0 on the other. And this one is definitely like that. So I can go 6x squared plus x minus 15. Okay, then look at the graph. How many x-intercepts do we see? How many x-intercepts do you see? 2, right? We see one is there and one is there. And neither one is lining up like right on the tick marks there. So that means, for example, which one of these answers could you throw out because it's not 2 fractions? See, I mean, like these are in between the tick marks. So it's not going to be an integer, a whole number. So these 2 cannot be then because it's not going to be -3, it's not going to be 5. Okay, and then the rest, for the rest of it, we should be able to estimate pretty well. Between those 2, I mean, does this look like it's more like the -5 halves? -5 halves is what? Turn -5 halves into a decimal. Say again? It's -2.5, so it can't be that. That would put it like 1 more over. So it's not, we know that it's not the 2 and the 4, right? Because of the integer values, right? We know it's not this one because -5 halves is like -2.5, and that clearly on the calculator it's not in between -2 and -3. That makes the answer C. Now, yeah.
You have the clear memory. Well, the answer's still on.
If your graph is, yeah, I mean, remember how to clear memory. 2 plus 7, 1, 2. I mean, that usually will get you back. This is another kind of particular problem, but yeah. I'm going them out of order. They're out of order.
They're all, so like, they're different, like they're the same, or I don't want them.
Huh.
They're there.
They're the same answer, yeah. So he just showed me that. You know, it seems like there must be more versions of this file out there. It's the same question, but it looks like the answers have been mixed around. But they're the same answers. So, you know, focus on what the answer actually is, not on the A, B, C, D. That's strange. I'm not sure how that happened. Okay. Okay, so let's go to the next one. So this is the kind of problem like we did here in the homework, which is, it's actually a bunch of letters, and you got to solve for one of the letters. And now when you see, here's the equation that we're solving for f, right? So it says f equals 3f minus 24. Now what would you have to do to isolate the f? Yeah, I mean, you got to get rid of the 24 and you got to get rid of the 3, right? Both of these things are the things to get rid of. So how do I move the negative minus 24? Add 24. Plus 24. So this is f plus 24 equals 3f. Okay, then what? Divide by 3, right? So then you're going to get divide by 3, divide by 3. So yeah, it might be out of order again, but I got to check and see that this is actually the correct f plus 24 over 3, which is which one? In mine, it's this one right here. I'll just focus on that. Now, there is another way you could do this. Usually what they give you to start out with is solve for one of the letters. And the 4 answers are solved for another letter. So what you can do is just make it up, like substitute some value for f in the original equation. Quiet, please. So just for this f equals 3f minus 24, let's just make up a value of f, right? Let's say that f equals, we could say 8, okay? F equals 8. Not 8, sorry. Yeah, f equals 8. Then in this problem right here, what does that make f equal? 3 times 8 minus 24. F equals 24 minus 24, which is 0, okay? So now go into these here and plug in f equals 0 and see which one you get 8 for f. Right? If I plug in a 0 here, what does f equal? 0 minus 24, negative 24. Can't be that. Right? Plug in a 0 here. 0 minus 24, negative 24, divided by 3, negative 8. Okay, this one. 3 times 0 plus 24. 3 times 24 is 72. Okay, that doesn't work, right? Now, 0 plus 24 is 24. 24 divided by 3 is 8. That's the one. So you can always just like, however many variables you got on the right side, just make up numbers, put them in, solve for the f, and then use those values down here to see which one is consistent with those values that you've got. It'll only be one. I mean, these are always hard questions for us, no doubt about it. What happened there? Okay. Okay, then we get to the system. Solving a system of equations. Now, we did this just now. We did this by substitution and elimination. How about let's do this one by graphing, right? So first, let's solve these two for y, right? The first one, 5x plus 3y equals 7. What is that going to look like when I solve it for y? I'm going to do it in one step. Watch. Negative 5x plus 7 divided by 3. Right? I moved over the 5x, that became negative, and I divided the whole thing by 3. And I'm not even going to simplify because we don't have to. We're putting it in the calculator. Okay, what will the next one look like if I do the same thing? Y equals. What goes in parentheses? When you move the 3x, what sign is it going to have? Negative 3x minus 23 divided by negative 5. Okay, so now we need to go to the calculator and put that in. I mean, do those two. And you could use fraction format instead of parentheses if you want. So I'm going to use the parentheses. Negative 5x plus 7 divided by 3. Enter. Negative 3x minus 23 divided by negative 5. Okay, I'm going to graph it to see what it looks like. See if I can see the intersection of two lines. Can I see the intersection of two lines? So then, again, what's the process? Yeah. Second, trace 5. Enter, enter, enter. And what is the answer? Negative 1, 4. Yeah, whether yours is D or not, it's negative 1, 4. Okay, then you put it in wrong. Negative 5x plus 7 divided by 3. 3x. It's negative 3x, not 3x. Okay? Oh, yeah. Okay, they're going to call us here in 2 seconds.
1, 2.
That was very literal of you, Ty. Okay, here we go. So we know that, usually there are system problems. Yeah. Okay, quiet, please. Quiet. Usually there's system problems that are word problems, so you're going to have to set them up. That can be a little bit of a challenge, but you practice, the more you see, the better you get. So, T-shirts and sweatshirts were sold at a local shop. One salesperson sold 3 T-shirts and 7 sweatshirts for a total of $240.50. Wow. Another salesperson sold 6 T-shirts and 5 sweatshirts for a total amount of $220. Based on this information, what is the cost of the T-shirt? So, what are the two variables? The two things we're trying to find out by doing this. Is it the amount of them? It's the cost, right? So the first thing you should do is define your variables. What are we going to call these two things? I'm just going to use X and Y. I'm going to call X is the T-shirt, right? And Y is going to be, X is the cost of a T-shirt, Y is the cost of a sweatshirt. Okay, now set up the two equations. 3T plus 7S equals 240.50. Okay. You see where he's getting this? Let me fill it in.
Teachers, at this time, we are having our tornado drill. Please have your students.
So I said I was going to use X and Y, but then I used the T and the S because somebody started saying that. But try to read this again and see why these equations make sense. Right? One salesperson sold 3 T-shirts and 7 sweatshirts, and it cost $240.50. Another salesperson sold 6 T-shirts and 5 sweatshirts, and it cost $220. That's where we got those two. Now, how do you solve that? Substitution, elimination, graph with the calculator. These numbers look kind of big. My bet is if I put this in the calculator and then I just went to the normal graph, I would not see the intersection point on the screen. What do you have to do when you don't see the intersection point?
Zoom 9 or Zoom 6.
Try again.
Zoom 4.
Zoom 3, right? Zoom 3 is zoom out. So zoom out so that you see the intersection. I'm not going to finish this one. That's how you set this kind up. But we do need to know how to solve systems. Well, here, this is the first one. We're using like T is X and S is Y. So I'll solve for S. The first one would be in parentheses, 240.50, right? Minus 3T, which is like X, divided by 7. The second one would be parentheses, 220, don't really need a decimal, minus 6T divided by 5. Right? You see how all those terms get there? Yeah. Yes, you could have. So you can see all I've done is I've moved these T terms to this side, which made them negative, And then I divided by the coefficients of that variable. Yeah.
Okay, if I just added those together and then
You add these?
Yeah.
What is it? But then you've like combined them into one equation which still has two variables. So that's not going to get you anywhere towards solving. So anyways, you put those in, you know, we could see that the y-intercept is going to be 30 something. So it's not going to be on the screen. So definitely zoom out, zoom 3, enter, and then it should be on the screen. Zoom 3, enter.
nothing.
Okay. When you graph with the calculator, there you do have to use X and Y. You can't use, like, can't put in the letters S and T. You got to use X and Y. Okay. So here's another one just to set up. Yes. Yes.
Can't you just log in, like go and like look at your answers and like how it says? Can't you just plug it in and be like,
Yes. I mean, a lot of these, quiet please, a lot of these multiple choice kind of questions, especially like for solve equations, if they give you, you know, like 4 possibilities, you can always try to just like back substitute and see which ones work. But then sometimes, you know, they'll figure out a way to make it a non-multiple choice question. Like the first equation that we solved, that was not a multiple choice. So let's see, how would we set up this system, right? Some plumbers charge a base rate plus an hourly rate. Okay, what does it mean then, the base rate?
That's what you pay them to get there, like to go to your house or whatever.
Okay, that's the part that doesn't change, right? And then the hourly rate depends on what?
How many hours they spend.
How many hours they go. So we could say plumber A, right? Plumber A would cost his base rate 35 plus what? X or H, whichever you want to say, right? What would the other guy be? 40 plus 12H. Again, now you would have to use X, but this is already solved for Y. Yeah, in the end, these are just costs, total cost. So go to Y equals, and on the first line, put 35 plus 15X. Y2, 40 plus 12X. Second, trace 5. Enter, enter, enter. So I think this is actually, I'm going to do this one. Might as well just to finish it off. Okay, Y equals, clear. So 35 plus 15X. Enter. 40 plus 12X. Right? When I see that on the graph, I see one line, I see another line, but do I see the intersection point? So zoom 3, and there's that, and there's the other. It kind of looks like it'll intersect, so second, trace 5. Enter, enter, enter. And what is this saying? 1.66666, which is what? That's like 1 2/3. Okay. Zoom 3, enter. Okay. So we're getting the value, the H is 1 2/3 hours. So which one of these is correct? What is 2/3 of an hour? No, 2/3. 20 minutes is 1/3. So it's 40. So which one of these is probably the answer they're looking for? The 1 hour and 41 minutes or more, right? Okay. Or more. Okay. So that's all we're going to get to now. The homework for tonight is about graphing lines, finding slopes, things like that we've done before. And we'll pick up with this stuff next time.